networking, and virtual switches. So we've got our virtual infrastructure configured. We've got it all stood up now, and although they're not connected into a virtual center server, we want to talk a little bit about a few of what we call the core four. Now the core four are processor, memory, networking, and disk. And we call these the core four, and in fact that's a VMware term because they're really the four major components that make up pretty much every server, every server anywhere. And it's these four components that VMware actually proxies the resources from the hardware into that virtual system whenever it's running on ESX or really Workstation or anything. And in this particular nugget, we're going to talk about one of these, and that's networking. With ESX, you get actually some very cool networking utilities and tools that you can do to do some complex networking arrangements. Now, we're not going to get really deeply detailed into these complex networking arrangements, but what you need to know is that with ESX, you get essentially the concept of a virtual switch. And this virtual switch is a layer 2 device that allows you to connect in your virtual machines, allows you to connect in your service console and even your vMotion network so that you can connect in all of that virtual stuff into the physical world. And we're going to talk a little bit about how you actually make those connections. We're going to look at ESX Nugget 1. We're going to see how you can reconfigure ESX Nugget 1 so it is appropriately configured. Now let's talk just a bit about a few items also before we get into creating those virtual switches about how virtualization is going to impact the networking in your environment. If you have virtualization involved in your environment, the very first thing it's going to do is it's kind of going to change what I'm calling the macroeconomics of networking. Now if I've got a VMware server, an ESX server in my environment, when I add that VMware server into my environment, it's absolutely going to change how I have to do networking for my environment. If you think about it though, a typical gigabit Ethernet pipe, right, runs usually about 3 to 5% on most servers. And so with the same thing with compressing processor and compressing memory use down, you're really capable of compressing down network use as well. And so if I've got my ESX server here, and on my ESX server I have a bunch of little workstations that are, or servers that are running virtually inside of my ESX, and I've got that ESX server running into the rest of my network, I'm going to encapsulate the communication between these virtual servers and the rest of my network. This is my intranet here, inside of the network connection that's coming out of my ESX server. Now, whether that Ethernet connection comes out as a single network connection or as a quad network connection or what, I have the ability to merge those network connections using Ether channel or using 802.3 AD, those sorts of ways of concatenating together network connections, both on the ESX server side and on the Cisco side or whatever your networking side is, to make the channel bigger. Now, again, back to this 3 to 5%. If I've got 10 workstations sitting on my ESX server, I'm still going to increase that to maybe 30 to 50% on my network connection. So when I'm looking at actually speccing out ESX servers, I want to spec out ESX servers so that they have the capability of using not only the available network to them, but also failing over those network connections too. I'm going to go ahead and minimize this, and I'm going to show you another picture of a good example of how we can configure our networking for our ESX servers. I like to draw a little box here in the middle, and I'd say ESX. Now, in order for us to perform all the functions that ESX requires, we probably are going to want to have a dual redundant connection coming out of our ESX connection, and that's for our production network. So if I have that, by having this in my production network, if one of my network connections goes down, still, if it's running at that 50% or so, if one of my network connections goes down, I have the ability to continue to access those servers. And remember, I've got 10 or 12 or more servers, virtual servers, sitting on this ESX box. So if I lose a network connection, I'm definitely going to lose a lot more access than if it was to a single server. I also need to have an interface that's coming out of another direction here for the vMotion capability. This is my vMotion interface. And so this interface is used anytime that I need to vMotion systems from one ESX chassis to the other. This interface is unnecessary if I'm not using the enterprise edition of VMware, but if I am using the enterprise version of VMware, it is good to have a separate vMotion interface because the process of doing vMotions can be relatively network intensive, and we don't want that process to impact our production network. Also coming out of the bottom here may be another connection for my service console, right? So again, if I'm heavily using my production network and I'm also going through a vMotion activity, I want to still be able to access my ESX server at its service console while all this is going on. Now that being said, the service console is the same location where the VIC connects in as well. So the service console, which is the Linux part of it, and the virtual infrastructure client need to have an interface to be able to get into ESX. This does not need to be a gigabit. So don't worry about that being a gigabit, but these days 100 megabit cards and gigabit cards really they cost about the same these days. So it's really 6 of one, half dozen of the other with server class. That being said, if I have external drives, if I'm using shared drives to a storage area network, I may need to have another connection coming out of the top or multiple connections coming out of the top, and typically those connections are also teamed. That may be an HBA and a fiber connection that comes out of the top, or that may be a copper connection and for an iSCSI connection. In either case, it's a good idea to have also connections that move out of my ESX server separated from the other uses so that I can connect into my disk drives in order to have the performance that I require. Now, whether it's fiber or whether it's copper, that's going to be an architecture decision on your part, but it's a good idea to have, if you're in the case of iSCSI, it's a good idea to have sometimes upwards of 6 interfaces that are coming in and out of my ESX server. Additionally, if my ESX server may be bridging networks, if my ESX server is sitting in a DMZ somewhere and I want to segregate that ESX server into a DMZ, I may even consider having a 7th connection coming out of my ESX server for purposes of moving traffic into my DMZ. So you can see that there's a pretty heavy requirement on the servers that you purchase to host ESX on having lots and lots of network connections, because you need to have redundancy and you need to have high performance as well. So whenever you're going to spec out those ESX servers, consider this as a requirement so that you have enough network connections to support what you need. So let's go ahead and move away from our picture here and take a look at our virtual infrastructure client for a bit. I've gone ahead and brought it up, and I've removed some of the toolbars in here so that we've got as much screen real estate as we can see. There are a number of toolbars up here at the top that you can add, and also a status bar down here on the bottom, but I'm trying to make it so that we can see as much screen real estate as possible. So we showed in the last nugget how to configure the VIC so that you can add the licensing in for your ESX server. What we also want to talk about now is specific about networking, and this is the networking information for this particular server. When we created this server, we added a single network interface card into this server. And as you can see here on the right, this physical adapter is currently connected into this little brown or little gray box right here. This little gray box is our virtual switch. Now, our virtual switch, again, is a layer 2 device. And what we mean by a layer 2 device is that it does not have any sort of layer 3 routing on it. You don't have to worry about too much of the VLANing, layer 3 VLANing and stuff like that. It is merely passing information from one place to the other. By having a single physical adapter in here, all of my connections and all of my configurations have to go through that physical adapter. Now, that's really not the best way of doing things. There are other ways that you can configure your switches so that you have separate virtual switches for the purposes of dividing network traffic out. You'll see here on the left we have a virtual machine port group. This virtual machine port group is when we installed the server, we said, did we want to create a virtual machine network for these virtual machines? This is that VM network. Our virtual machines, once we start adding in virtual machines, will be showing up, and they will be using this virtual machine port group in order to connect to the outside world. We also have here a service console port, and this service console port is what we use to actually connect into our infrastructure using the VIC and using the Linux connection. So if I'm using a PuTTY or SSH to SSH into my environment, I'll do that through this service console port right here. If I click the properties of this virtual switch, I see a number of options that we can set up for not only configuring the virtual switch, but for connecting the items to the left and the items to the right of that virtual switch. The very first thing you'll see here is that by default, a virtual switch contains 24 ports. Although the number of ports that I can create for that virtual switch climbs to upwards of 1,016 ports for that virtual switch. If you have a lot of virtual networks that you want to create, then you may need to increase the number of ports on that virtual switch. If you do make the change there, that's one of the few changes that requires a system restart to actually complete that process. We have the ability also to do some policy exceptions, some securitization of that part. You know, say we are currently rejecting promiscuous mode information. So if we have promiscuous mode on a card that is trying to just snoop what's going on inside my switch, I currently have the security set to reject any of that promiscuous mode traffic as it goes about. I also am allowing my virtual machines to do MAC address changes and forced transmits. What a forged transmit is it's any outbound packet, any outbound traffic that has a source MAC address that is different than the one currently set on the adapter. So it's trying to transmit data that it doesn't actually appear to want to receive because its MAC address is wrong. So if you want to lock down that virtual switch, you can change these settings from reject to, or from accept to reject. Be aware that there are some applications that require forged transmits or MAC address changes in order to be supported. If you're doing MAC address spoofing like a load balancing, Microsoft load balancing, and LBS requires some of these to be able to function so that it can spoof MAC addresses, and it's an appropriate use of MAC address spoofing. In the next tab, we have the ability to alter some traffic shaping capabilities, and if we enable traffic shaping, we can change the average and peak bandwidth, and also the burst size associated with the traffic coming in and out. This changes how much potential traffic we can move in and out of our network on average over a period of a peak period, and then also the burst size, the maximum number of bytes to allow when a burst occurs. Under NIC teaming, this is the ability, it gives us the ability to change how our NICs are teamed. Since there are a lot of ways that you can actually set up load balancing on NICs, there are a number of different ways associated with whether or not that is based on originating virtual port ID, whether it's based on a hash of the IP or a hash of the source MAC, or if you want to use an explicit failover, if you know that you want to go from this card to this card to this card, once you have NIC failover. Typically, you leave these kind of the same. There's really not a lot of true need to update these unless you have specific needs to. Whenever you do have a network failover, you can do that either by checking the link status, or you can actively have the ESX server probe out or beacon out to see if there's any issues that are currently going on. Beacon probing involves some resource use, but it actually does find some issues that are not normally found by doing link status only. Do you want to notify the virtual switches whenever you do have a network failover? By notifying those virtual switches, you will reduce the latency involved with actually switching the traffic over from one to the other when you have a failover event. And lastly, do you want to roll that failover, and do you want to set up the failover order associated with that rolling failover? You'll see here that we only have a single NIC right now. We'll be adding additional NICs in just a minute. But if we have multiple NICs, we can set NICs as either active or standby, or even set them as unused if necessary. All this is available here inside the properties of this switch. So we see here that we're looking at the properties of our virtual switch. We can also view properties of the VM network as well. The VM network gives us the ability to give it a network label. Once we give it a network label, we can also, if we're using VLANing on our network, we can apply a VLAN ID here also. You'll see here that we're not using VLAN IDs in this particular demonstration. But if the network that this network card is connected to has a VLAN ID that we want to use to restrict traffic, we can apply that here. If you'll remember, in the last nugget, we had the option of choosing the VLAN ID for the service console. Here we have it also to choose for our virtual machines switches as well. Same thing as before with security and traffic shaping and NIC teaming as well. Here, all of these capabilities are for our VM network that is currently connected into that switch. Lastly, it's the service console. We can also choose edit, or we can choose to modify items on the service console. And what you'll see here is that if you try to make any modifications to the service console, it's going to give you an error message. And the reason for that is that we are currently leveraging that service console in order to manage the system. And if we make a change that actually disconnects the network or moves around the network in a way, we could potentially lose access to continue managing our system. And so what they're saying here is before you actually do any changes to the service console, any changes to the configuration of the service console network, it's probably a good idea to create a second service console network and ensure that that one is operational. And if you think about it, having to go into the Linux and actually reconfigure the service console network is going to be quite a bit more difficult using the command lines than using the virtual infrastructure client. So it's always a good idea to create that second service console connection in case what you're doing when you're modifying that connection may make a change to it. The big difference here, as composed to the other ones, is the ability to change the default gateway for that service console. You'll see here, here's the IP address and subnet mask associated with the service console and the default gateway. The same thing tier 2 in terms of VLAN ID, security information, shaping, and teaming information as well. So all of this is available for us to configure the ports that are set up on the switch. This is, again, the left side of our switch. On the right side of our switch are the network adapters. And currently, we have one single Intel 82545 gigabit Ethernet adapter using the E1000 driver. We have one of these drivers currently connected in on the right side. So right now, we are not doing any kind of load balancing, and we are not doing any kind of failover for our networks because we only have a single card. If we wanted to add in additional cards here, you'll see that I've gone ahead and created 2 additional network connections on the properties of this VM so that we can add these 2 network connections in to our network to be able to make use of them. Let me show you what we did essentially is if we went back here into the properties of our VM our ESX server back in Workstation, what we've done is gone to the Settings tab and added 2 more Ethernet adapters here. Once we added those Ethernet adapters, if you remember back when you had to go and hack into that VMX file, we had to hack the VMX file as well to make those Ethernet adapters available. You only have to do that hacking of the VMX file because we're here inside of Workstation. So that being said, though, we have 2 new adapters that we can actually play with now and add into our infrastructure. If we click Next, we can show the policy failover order and the active adapters and the standby adapters. And then click Finish to actually add those into our environment. You'll see now that we immediately have access to the other adapters. Now, what's important here is that in order to fully use these additional adapters must be configured at the network switch level as well. You have to configure the network switch to be aware of if you're using Ether channel, if you're using some sort of network teaming capability to team these adapters together, you're going to need to do that at the network switch level. You'll be able to configure these inside of ESX, but you're going to have your network guy also configure them at the network switch in order to fully function them. Once they are actually enabled, there's no reboots required, but as soon as they're enabled, and as soon as they're enabled actually at the network level as well, you're going to immediately begin to use them, whether they're failover or load balanced. You're going to immediately be able to use them for your virtual machines, and in this case also for the service console. One reasonable way that you can determine whether or not your network connections are set up correctly at the Cisco side, at the network side, is also to switch over here from the networking node to our network adapters node. I'm going to click here now, and if I click on the network adapters node, you'll see this networks item that's here. This networks item does a best effort to try to show the networks that this particular network adapter is currently configured for based on your network. You'll see here that these are the networks that are currently configured for these three adapters. If these networks are correct for what you intend your ESX servers to be installed onto, for them to be running off of, then you have a pretty good reasonable expectation that the network configuration is functioning to properly do the load balancing and properly do the network routing between your network adapters. Now, what I said before was that it's a really good idea to separate out some of these adapters so that you're not running them all off the same virtual switch. And again, that's so that you don't end up filling up one network adapter or having the use of one network adapter impact the use of another network adapter. And so what we're going to do now is we're going to separate out these physical adapters and point them to 3 separate virtual switches. And by doing that, we're going to segregate our network traffic, just like we did before here with our graphic that we showed earlier. We're going to segregate out that network traffic as best as possible. Now, unfortunately, VMware Workstation, the system that we're using to host this ESX environment, has a limitation of 3 network adapters. So we're not going to show all 7 adapters here. But what we are going to do is take the 3 adapters that we have available to us, connect one into the VM network, one into the service console port, and then the third into a vMotion port. And the vMotion port will be used later on when we attempt to set up vMotioning so that it will actually do the vMotioning back and forth using that vMotion interface. In order to do this, we need to go back into network adapters and actually remove the 2 adapters that we added previously. By removing these 2 adapters, we make them available for use for the other networks. So now we have VMNIC 0 that is currently being used by VMNIC 2 that is currently being used by this initial vSwitch. If we want to add in networking, we can add in another networking, for example, for the VM kernel. If I click Next here, I'm going to choose VMNIC 0. It's an available network card that's not being used, and we're going to create a new virtual switch for the purposes of this VM kernel port. If I click Next here, I've got to get a network label, I've got to get a VLAN ID, and I've got to get an IP address as well. Anytime that we're creating VM kernel ports or service console ports, we have to have IP addresses for those ports to be able to do the routing between them. Anytime we're doing virtual machines, the virtual machines themselves will handle the IP addressing, and so we won't actually have IP addresses for the switches when we're creating those ports. So let me go ahead and I'm going to put in 192.168.0.103 and then my subnet masks in here for this VM kernel port. We click Finish, and we need to set up the default gateway. Just like everything else here, the default gateway in our group is 1.1. So we do 192.168.0.1. This is for both the VM kernel and for the service console. If we have a DNS server in here, we can configure our DNS server as well. We have a name and a domain that we created as part of the installation of our ESX server. And then we also have DNS server addresses in here. We only have one in this network, 0.70, but if you have a second, you can put your alternate DNS server in here. So I'm going to click OK, and you'll see now that we have a second switch that we've created. The first switch was our original switch with the service console and the virtual machine port group, and we have a second switch here for the purposes of segregating that VM kernel traffic. The next thing we want to do is actually we want to remove the virtual machine port group here and put it into its own virtual switch. So I'm going to go ahead back into properties, and I want to remove this VM network port off of this switch, and I'm going to add it into its own switch. You'll see here that it now completes, and we hit close, and you'll see that we no longer have it on our original switch. I go back to add networking, create a virtual machine port group. I add it to my existing NIC that I have available. I click next. I don't have a VLAN ID for it, so I click next again, and the new port group is complete. I have now successfully segregated the traffic across, so my service console has its own port, my VM kernel for the purposes of vMotion have its own port, and all of my virtual machines here on this lower switch, VM switch number 2, now have their own network adapter for the purposes of their production network interface. I want to finish out this nugget by talking just a minute and revisiting the concept of DMZs. As you can see here that we have the ability of creating these logical separations between port groups. And it's a really handy idea whenever you have a server that needs to operate inside of multiple locations, multiple network locations. Maybe you have a number of different VLANs that you need that server to operate on, or maybe those VLANs correspond to a number of different DMZs that you want that ESX server to operate on. It is completely legitimate for you to have an ESX server that actually bridges multiple VLANs or bridges multiple DMZs because of the logical separation of these ports. Obviously, you're going to have that network interface card in order for that traffic to go out on. You can't share a network a physical card that's on multiple VLANs or multiple DMZs. So you have to have the multiple network cards, but it is completely capable for you to create multiple port groups based on those VLANs. Let me go back and show you a picture of this once again. And we've kind of already taken a look at a picture of this, but let's go ahead and create another picture so we can see exactly what we mean by this. We'll go ahead and create this picture here and then put this back in a full screen mode. Let's think of it again where I've got, let's say, the internet over here, and I've got maybe I've got an initial firewall here, and oops, that's a very terrible straight line. So I've got my initial firewall right here. I've got my DMZ right here, so I've created a DMZ, and then I've got over here is my internal network. So we'll call this the internal network, right? And these are firewalls, or at least the demarcations between the DMZ and the internal network. And the way it typically works is traffic comes in from the internet, it goes into a server that sits over here in the DMZ. Again, maybe it's a web server like our previous example, and then that web server sends information back to the internal network, or the second hot DMZ, maybe back to its database, for example. Well, with ESX, you have the ability of sort of hybridizing these two roles by sticking your ESX server between the demarcations of the DMZ and the internal network. Now, we're not necessarily saying that you're bridging so much in a physical sense, but in a logical sense here. What we can do is we can create a port group that goes out this direction onto the internet. Maybe that's VLAN 1, VLAN 1, and VLAN 2 is on the inside network, and that actually connects into the database. And so now we have inside of our ESX server, we have the ability to, maybe we put our web server here, and we put our business logic server over here, and the business logic server connects into that VLAN 2, and the web server connects into that VLAN 1. So we have this capability of doing this logical separation. And if you have multiple VLANs, and if you're more than a really small environment, you probably have multiple VLANs. Be aware that you can make use of this to make the process of having to buy additional servers just because they need to be separated by VLANs that much less expensive and that much easier for you. So let me go ahead and minimize these. What have we talked about today? In today's nugget, we talked about networking, we talked about virtual switches, and we talked about how virtualization impacts networking. We also talked about kind of the macroeconomics of networking, how you can take what is generally a not very well used network connection at 3 to 5% and squish it together like you're doing with processors and RAM inside of VMware to better use that available networking. We talked about how to create virtual switches and configure virtual switches, and then we also talked about ESX networking options as well. And lastly, we talked about networking in the VM and how you can put your VMs into different port groups to allow you to access different VLANs for the virtual machines that are on your ESX server. I hope this has been informative for you, and I'd like to thank you for viewing.